a little bit tougher to pick up. Before I get to dilation, though, I just wanted to throw a vocabulary term at you before we start dilations. Invariant points. Invariant points. So I want you to pretend we got point A, and I ask you to do a reflection, rotation, or translation, and point A prime is in the same spot. A never moves. Okay? We say those points are invariant. So it's a point that does not change position after a transformation. Does not change position. After a transformation. Stays exactly where it is. Invariant. That point is invariant. It does not move at all. So I wanted to do two quick examples with you guys to make sure we got this clear. I don't need you to graph it at all. Don't graph. I'll do a quick sketch up here. So I got this quadrilateral ABCD. I'm not going to graph all of it. What I need you guys, you guys are above average group, they tell me. So I'm going to ask for two transformations here that make point B invariant. So point B, 0, -3. There's point B. Can you guys give me a transformation with a specific rule that B prime is going to stay right where it is? Don't be the funny kid who goes, oh, I'll do a translation of 0, 0. Or a rotation of 360. All the way around. No, let's give me something here. Okay, give me something where point B prime is going to be exactly where it is right now. Via, got something?
Yeah, sure. A rotation -90 degrees.
Wouldn't that be over here now? Or over here, -90?
-90.
Yeah. So clockwise, that would make B prime right here now.
Is that a bad thing?
Well, what's invariant? Where's B prime got to be? Right there.
Yep.
But now B prime's going to be right here now. It moved. I can't move anywhere. Got me? Can't move anywhere. I need B prime to be this point as well. Good?
Oh.
It stays where it is. It does not move. See what I mean? Okay. Scott, got something?
Point reflection of 0, -3.
Okay, so reflect through the point it actually is.
Yeah.
All right. Got clever there. Yeah. So reflect through the point 0. It works. Yes, it works. I'm trying to get a little bit higher here. All right. Translation to 0, 0. Rotation to 360. Romeo.
Reflect over the y-axis.
Can I reflect over the y-axis? Is that all right? Yep. So reflect. First thing we could do, reflect over the y-axis. It was correct, Scott. It was fine. It was fine. I want another one, though. Come on. Dig deep now. What else could I do to point B where it's going to land and not move anywhere? Land right where it is. Come on. Without doing some of the basic stuff here. Think you got something, Zach?
Yeah.
Better be good.
Rotation around that point.
Okay, I could rotate around that point, and it's going to stay right there. Yep, good. I'm looking for something else, though. Yep. Rotation around point B. Nothing, huh?
Yes.
I mean, you would want a translation.
No, because I don't want 0, 0. That got something, Luke?
Reflection over x equals 0.
So the y, it's the same as the y-axis. Okay, so we already have that up there. You guys are killing me here. I'm looking for a reflection, by the way, but over a different line. Not the y-axis. Josh?
Reflection over x equals 3.
That's this.
Y equals 3.
Y equals 3. Yes, everyone. The horizontal line, y equals 3. Right? Hey, right here. Everyone agrees I reflect B over that line. It's not going anywhere. Okay, good. All right. Oh, boy. Should I even attempt this next one here? Here we go. Point D is 3, 0. Give me a couple transformations that'll make that invariant. And again, no 0, 0. What do you got for me? All right, Via, second chance.
Reflection over the x-axis.
There you go. Reflection over the x-axis. I'll keep it right where it is. And what else will keep it where it is? What else will keep it where it is? Go ahead, Callum.
Reflection over x equals
Now I want that reflection over x equals 3. Good work, everyone. Good work. All right, so invariant. Everyone all right? All right, next time you might see that word is on the test on Tuesday. All right, invariant. All right, let's start talking about these dilations here. Because there's a little misinformation out there. Dilation, and I get it. You guys think, oh, something's getting bigger, something's getting smaller, right? That's what you guys probably think from your middle school days. Oh, dilation, something's getting larger or smaller. That is true. But what happens when you dilate an actual point? I hate to break it to you, the point doesn't get physically bigger. All right, that's not what happens. I hate to break it to you. Here's what happens. All right, here's what happens with a point when it gets dilated. We will always dilate around a center point, a center. So take a look at my first example here. This point right here is my center point, the point we're going to dilate around. Now, does everyone see point A right here? Point A. Now, did point A get physically bigger? No. What happened to point A? Did it get closer or further away from the center? Here's A prime. Did A get further away or closer to the center? Further away. So did B, and so did C. Everyone agree? That's what happens to a point. It gets further away or it gets closer, like in the second example, to the point we're dilating around. All right? It does not get bigger. It does not get smaller. It moves. It moves. Points either move further away when they're dilated or closer when they're dilated. Closer to what? Further away from what? The center. Okay, the center. So real quickly, by how much they get further away or closer is called the scale factor. Okay, it's called the scale factor. Everyone see, did my triangle get bigger or smaller than the first one? Bigger. Why? Where did all the points go? Further away. So that's why the triangle got bigger. How am I going to tell just by the scale factor whether it's going to be a bigger figure or a smaller one? Well, this was a scale factor of 2, and it got bigger. So what do you think? If the scale factor blank, it results in it getting bigger. Callum?
under 1.
Under 1? This one was...
No, for bigger, it's over 1.
Over 1. So greater than 1. Yep. So if your scale factor is greater than 1, everyone, it's going to be enlarged. All right? Enlarged. What if it gets smaller? All the points get closer to the center. Here, it was 0.5 and that happened. What do you know about the scale factor now? And a lot of you maybe just want to say less than 1. Right? Less than 1. I need a little bit more detail. Ready? Scale factor between 0 and 1. All right, we're not going to deal with negative scale factors in here, so that's why I put between 0 and 1. All right, so if it's between 0 and 1, the points get closer. So is everyone dilation? Points get either further away from the center or they get closer, and we can tell what's going to happen based on the scale factor. If it's bigger than 1, they get further away. If it's less than 1, between 0 and 1, they get closer to the center. All good. Yes, Via.
So if it's like less than 0,
That's a negative scale factor, which we're not going to deal with.
yeah, so that figure is most likely going to be moving towards the other side, I'm guessing.
Of the point, that's what would happen. Yes, it's actually a reflection too, but I only want to stay positive scale factors. All right, I don't want to go in the negative direction. All right, so here's our big task today. Tomorrow we're going to dilate points. Today I want to dilate a line. Okay. Now, think about a line, not a line segment, a line. Does it ever end? No. So can a line get physically bigger or smaller? No, that's impossible. All right, because it goes on forever. So when we dilate, it's not going to get bigger or smaller, but it is going to move. All right, it is going to move. All right. So let's take a quick look at how they move. O is our center. O is our center. And I want to dilate AB from O. Okay, from O. I'm just going to, let's just say scale factor 2. We'll just pick scale factor equal to 2. Guys, is the line going to get bigger? No, that lines can't get bigger. They go on forever. But look at everyone, highlight point A right now. Is point A going to get further away from O or closer to O? Further away or closer to O? Why further away? Because the scale factor is greater than good. All right, so now let's do our best right now to move it away, further away from O. So right now, everyone see, and I'm just going to do this on my diagram. O is a certain distance away from A. I want to double that distance now away from A. All right, double your distance, and that'll be A prime. So I doubled my distance away that A is from O. Point B, is it going to get closer to O or further away? Further away. So right now, O has a certain distance from B, and you're going to double that distance right now and call that B prime. And do your best. I know I didn't ask straight edges today. Do your best and go ahead and graph in AB. You just dilated AB by 2, and that's what it looks like. And I'd like you to make one observation about this. What do you know about the 2 lines? Use a nice little geometric term here. When I dilated a line, the 2 lines are still what? Zach? Parallel, yes. Lines are parallel after dilations. Okay, get it out of your mind that the line becomes physically bigger or smaller. It doesn't happen. All right? Lines are still parallel, though. Does that make sense? Do we see how they come further away, but the lines are still parallel? They just move. That's it. They're either going to move further away or closer to the center. That's it. Questions on dilating a line, because I got a challenge one for you now. Special case. Special case. Some of you can relate. All right, special case. Look where I put the center now. Where's the center now? On the line, we're going to dilate. Does that make a difference? Well, let's see. Here's A. And let's say, all right, here you go. Let's go scale factor. I'll go 1/2. Let's change it up. Scale factor 1/2. Is A going to get closer to O or further away? Further away or closer to O? Closer. Where's A prime going to be? Where's A prime going to be when I move it closer? Still where, Luke?
On the line.
On the line, isn't it? Look, let's move A prime a little closer. All right, there it is. Still on the line, isn't it? Is B going to get closer or further away? Closer. And where's B prime going to be? Still on the darn line. So what can you tell me about my new line here? My new line is same as the original line. Everyone see that? So here's the thing. You got to remember, when you dilate and the center is on the line, it remains the same line. Okay? Remains the same line. Okay? So if your center of dilation is on the line you're dilating, The new line is the same line. All right, new line is the same line. If it's off, it remains parallel. That's what we got to remember. If it's off the line, it remains parallel. If it's on the line, it stays the same line. All good. All right, let's start grinding these out here. I got this equation here. Line N, 3x plus 4y equals 20. We're going to dilate it. We're going to dilate it. It's not getting bigger or smaller. It's moving. Maybe. Maybe it's moving. We'll see. What's my center point? What am I dilating around? What's the center point of dilation? 4, 2. And a scale factor of? Okay, quick question. Are all my points getting closer to 4, 2 or further away if it's 1/3? Closer, closer, closer. All right. Can we just take a quick peek at what this line looks like on the graph that we're dilating? I'm pretty sure all of us in here don't like the way this is written. If I ask you to graph it, you like it in y equals form. So can you help me get it in y equals form? First step to get it in y equals form. Hasn't been that long, has it?
Move the x over here.
Get rid of 3x, subtract it over. So what do you got? 4y equals negative 3x plus 20. Almost y equals form. What's the last thing you got to do? Divide by 4. Divide by 4. So here's the same equation, but just in y equals form. Negative 3/4 x and then plus what? 5. All right. Can you guys help me graph it back in your Algebra 1 days last year? First point I can graph is what? What's my y-intercept? 5. Everyone go to 5 on the y-axis. 1, 2, 3, 4, 5. There it is. And then can you use the slope to get a few more points? Where do I go here if I'm going to use my slope? Whew. Down 3. 1, 2, 3. Right 4. 1, 2, 3, 4. Down 3. 1, 2, 3. Right 1, 2, 3, 4. Okay, there's a line. Do your best. Nice straight line through there. Okay, there's my line. We're going to dilate it. All right. Quick reminder for me. What's the center again we're dilating around in this one? What's my center of dilation? 4, 2. Can you guys figure out where 4, 2 is here? Something interesting there, huh? Over 4, oh. Oh. Is this line going to move anywhere? If I'm dilating around a point that's already on the line, is this line going to move? Nope. Look, you can try it out. Look, this point's going to get closer. Great, it's still on the line. This point's going to get closer. Great, it's still on the line. Does everyone see how when your center is on the line does not move anywhere? We're done. So what's the equation of my new line here? State the equation of line P. I got to start calling on people now. So what's the equation of line P then? If it didn't move anywhere. Probably watch 9 here. 9, what's the equation of my new line?
The same, so it would be 3x plus 4y equals 5.
Yep, or you can use the y equals version we just graphed. Either one would be acceptable, correct. So there's my new line. Does not move when the center is on the line. Are we okay on that concept? Because this next one, the center is not going to be on the line, and we actually do have to move it. All good? All right, let's do it then. What happens when I don't have a center on the line and I got to move it? All right, next up. What's the equation of 3/2 x minus 4 when I dilate it by 3/4? And where's my center now? Centered at? Origin, 0, 0. So there's my center. A little help graphing it. 3 halves x minus 4. What point can I graph first? Let's roll. 15. -4, everyone. Y-axis. 1, 2, 3, 4. Use the slope. Give me another point here. 3. Where can I go from here? Up 3. 1, 2, 3 over 2. All right, I just need it up 3 over 2. That's all I need. I don't need the actual point. You're good. And then let's do it again, everyone. Up 3 over 2. 1, 2, 3. All right, there's the line I'm going to dilate. Reminder to your classmates, what point are we dilating around? Where's the center here? 18, where's the center? We have center of dilation here. Where am I dilating around? Where's the center? Origin, 0, 0. Now, does everyone see, is 0, 0 on the line? No. So it's not going to remain the same line. It's going to move, actually, now. Scale factor 3/4. Points getting closer or further away? Closer. All right. But if I go back in my notes, what am I going to know about my new line? It's going to be parallel to the original. All right. If it's parallel, they're going to have the same slopes. So I already know my new equation is going to be y equals 3 halves x, and then I got to figure out the rest. All good? Why it's 3 halves x? Because they're going to be parallel to each other. Now, what do we need to figure out? The y-intercept, right? What the heck's that's on us now? What's the y-intercept? And I'll make it very easy on you guys. What's the y-intercept right now for this line before I dilate it? 16, what's the y-intercept now? Y-intercept. What point did we graph on the y-axis? 3 halves x minus 4. What is your y-intercept? Okay, it's -4. And is it going to get closer or further away from the origin? Closer. Now I take the scale factor, 3/4, and I multiply it by that y-intercept. So I take my scale factor, multiply it by the y-intercept. And that'll produce the new y-intercept. So -4 times 3/4. Ends up being -3.
Oh, yeah.
That was your scale factor. It's getting 3/4 closer. So I just took -4 and multiplied it by the scale factor. All right. They're parallel, slopes remain the same, and I multiply my y-intercept by the scale factor. So what do we got there? Choice 4. Questions? All right, let's keep going here because 2 definitely doesn't make us great. No shot. All right, go ahead. Read through 3 real quick. Read through 3. No graph here, though. I don't want a graph or take the time to graph anyway. So I'm taking -3x plus 6, dilating it by 2. Around what center? Because it's not the origin anymore. 8, what center am I dilating this around? No 8? Okay. Try again and again. 15, what center am I dilating around? Okay, 0, 6. All points getting further away, right? Because it's a scale factor of 2, further away from 0, 6. Anybody notice anything? This line I'm dilating around 0, 6. This line I'm dilating around 0, 6.
So it's still the same.
What's the y-intercept here?
6.
Isn't this the same point? 0, 6? So what do you know about 0, 6? It is? It's on the line, isn't it? And what do we know about if we dilate around... do I really want to embarrass you in front of everyone right now? Make sure you tell your buddy I said hi. Okay, tell your buddy I said hi. All right, Mr. Carlino says hi. All right, it's bad enough you two back there go back and forth with your little cute notes, and now you're going to take your phone out. All right, good. A lot of respect there. Everyone agrees it's on the line, right? Correct? On the line? What do we know about if it gets dilated when the point's on the line? Stays the same line. There we go. Stays the same line. So this is still going to be negative 3x plus 6. Now, I get it. Some of you are like, how in the world does he... I would never have noticed that that point was on the line without graphing. And I get it. So let me just show you how to do it algebraically real quick without graphing. How do I know 0, 6 is on the line without a piece of graph paper in front of me? What coordinate is this? 0. What coordinate is that? That's the x coordinate, right? X coordinate. So plug it in for x. Watch. Negative 3 times 0 plus 6. What's the 6? That's what coordinate? Y. What do you get over here? Negative 3 times 0 plus 6. They'll equal each other. If the point is on the line, you should be able to plug it in for x and y, and both sides will be equal. All right, that's how you know if a point's on the line or not without having a graph. All right? Anything. Point on the line, no change. Point not on the line, same slope, multiply by the scale factor to get the y-intercept. Good? All right, here you go. Let's keep working here. So here's Aaliyah. 4x plus 3y equals 24. We're going to dilate it by 2 at the point 3, 4. What's she saying? That's the new equation. Is she correct or not? Well, hey, ready? Let's just try out what I just showed you guys. Can we just test if 3, 4 is on the line or not without graphing? Even though I provided graph paper. Here, let me show you. What's your x coordinate? 3. So does 4 times 3 plus 3 times, what's my y coordinate? 4. Is that equal to 24? 12 plus 12? I think it does, right? So is 3, 4 on this line? Is it? Is 3, 4 on this line? Yeah, it is. So my answer should be what? What's my new line going to be? If my center's on the line, what's my new point? Same line, right? Well, I don't know if she's right or wrong yet, right? Because she did it in y equals form. I don't know. She might be right. We got to put it in y equals form to see if she's actually right or not. So let's go 4x plus 3y equals 24. All right, let's put it in y equals form because we know this is our answer should be the same line. All right, a little help doing that for me. 2, first step. I don't want to move. I want to try to get the y by itself. Minus 4x, minus 4x. 3y equals negative 4x plus 24. Next step. 5. Divide everything by 3. All right, so here is our equation. It should be y equals negative 4/3 x, but plus what? 8. The answer should be negative 4/3 x plus 8 because the point was on the line. Is she correct? No, not correct. All right, not correct. This should have been my answer here. The same line I started with. And I'm going to hold off on the last one until tomorrow. I want to hold off on that because that bridges us into tomorrow. There's only 3 problems, and that's not a mistake. There's only 3 tonight. I only needed 3 to get the point across. All right, so try them out right now. See if you can do them on your own based on what we've talked about today.